Alright, so this is a video for reviewing Unit 13, which is all on slope inferencing with confidence intervals and hypothesis tests. We're also going to be bringing back in linear regression, so you will have to know a little bit of that. That was all the way back from first semester in Unit 3. What exactly do you have to know for this test coming up on Monday? It would be very helpful for you to have memorized your conditions and assumptions. Remember that there were 4 conditions and assumptions that you had to know. So remember that the first one and the third one you always assume, and then the second and the fourth one you're going to show the relationship is linear with a scatter plot and the normal distribution with a histogram most of the time. Another way you could show linear relationship is through the residual plot, and another way you could show normal distribution is through a quantile plot. But the two that we're going to focus the most on are the scatter plot and the histogram. These formulas are also not on your formula sheet, so this b sub 1 plus t and then se sub b, that is not on your formula sheet. Neither is the standard error for slope. So these two you really have to have memorized. And the standard error for slope also comes back in with hypothesis testing. So you need to have this memorized and this memorized as well. We then talked about the least squares regression line, which, if you remember, had the form of y hat equals a plus bx where a is your slope, excuse me, a is your constant and b is your slope. Now, in Unit 3 we talked about how also y hat equals b sub 0 plus b sub 1x is also the same thing. So a and b sub 0, this is still your constant, and b sub 1 is still your slope. Okay? As far as residuals are concerned, residuals are calculated by y minus y hat, or observed values minus the predicted y values. We did a whole review on your note packet with the residuals as well. So as far as your confidence intervals were concerned, this was example 2 that we talked about during class time. Again, you're going to see the scatter plot, which you do need to sketch, and also the histogram. If you want to find b sub 1 is the slope of the line, and you can find that by calculating the LSLR. And again, the LSLR is here. In order to get that, you would want to hit Stat, and then arrow over to Calc, and then arrow down to option number 8, which is a plus bx form. Okay? You also can do a 1var stats to get s sub x, and you will need to plug that in if you have the actual data, and I'll be showing you that on the calculator in just a minute. The t value is, again, your t value from your inverse t function. So you want to do inverse t, and then your percentile, comma, degrees of freedom. Alright? Now, if you have an old calculator, we gave you a program for slope integer or program, so you'll want to use that. If you have the new calculator to do an interval, there is an option lin reg t int that you can do these on. Okay, we then from there went on to talk about mini-tabs. In your mini-tab, just be sure that you understand that this is your slope and this is your standard error of the slope. And of course, this number right above your slope is the a value. This is always going to be the x label, and then of course your y label will be the other variable. So in this problem, if it's age and height, age we already know is x from the mini-tab, which means y would be your height. Whenever you write the y hat a plus bx, or the least squares regression line, you're going to want to define both variables. It's just a good habit to get into. You also have your r squared value, and then you could take the square root of that in order to find your correlation coefficient. But other than that, remember that when you do your Conditions, you do have to assume all conditions because there is no raw data, so it is very important that you would want to proceed with caution. And since this whole thing is your standard error of B, you would just substitute that number straight into that formula here. Okay. We then took a look at some problems with hypothesis testing. In hypothesis testing, you always start out with a null hypothesis of beta equals 0, which means there is no linear relationship. And then your H sub A is going to be dependent upon what you are trying to test. Same for assumptions and conditions. Your test statistic T is your slope divided by the standard error of B. You'll see that again. Standard error of B has not changed. Again, that's a formula that you must memorize. This is not given to you. Neither is this one, so you have to have those memorized. Your degrees of freedom is still n minus 2 here, and your p-value, you're going to use your TCDF function because you're back to t-values. Okay, lower bound, upper bound, and degrees of freedom. And again, this was an example that we did from example 5. Again, you'll see the scatter plot in the histogram. Make sure that it's a normal distribution. If it's not, you're going to want to make sure you proceed with caution. This was a two-tailed test, so that's why we multiply the probability by 2. And then you have your same summary at the end. And then, of course, using your calculator, I wanted to go over the more practice that I gave you in class today. So first of all, in number 1 in the more practice, if you remember from before, I said that y hat is equal to b sub 0 plus b sub 1 x. B sub 0 and B sub 1 are actual formulas in your packet. B sub 1 is given to you in your packet as r times the standard deviation of y over the standard deviation of x. So therefore you just use those values that are given to you in order to calculate B1. Once you have B1, in order to calculate B sub 0, you take the y bar and you subtract x bar times the B1. So once you get all that and substitute, then you'll be able to find out your LSLR. So here I'm going to take B1 equals 0.8 times 4.2 divided by 5.1. Okay, and then in your calculator again, you're going to want to just multiply 0.8 times 4.2 divided by 5.1. So your B sub 1 value is 0.659. So then you're going to use that when you calculate B sub 0. You're going to take y bar, which is 15.6. You're going to subtract x bar, which is 14, times the B sub 1 you just calculated, which was 0.659. So you're again going to go to your calculator. You're going to take 15.6. You're going to subtract 14 times 0.659. Or you could just put previous answer in there. And you're going to get 6.374. So your equation is going to be y hat equals b sub 0, which is 6.374, plus 0.659x. Okay? Now as far as putting data into your calculator, you're going to want to go ahead and get this data into list 1 and list 2. So in order to do that, you're going to hit stat, enter, and you're going to enter this data into a list. I'm going to pause the video just to save time while I'm entering this data. Okay, so now that you have this data in your calculator, in order to find the least squares regression for the data, you're going to press stat, calc, and arrow down to option 8, which is your a plus bx formula. You're going to press enter, and it's going to give you the equation. So y hat equals 2.771 plus 2.153 x. Okay. What is the test statistic and p-value for a two-sided significance test for the slope of the regression line? So that's just literally going to be, and I can't show you, well, I guess I can't show you on this calculator. Oops. So you're going to press stat and arrow over to tests. This doesn't have the confidence interval on it, but I can show you at least the LinReg t-test here. So you're going to press enter, and it's going to ask you where your X list is, which mine is in list 1. My Y list is in list 2. Leave your frequency as 1. And since this is a two-sided significance test, it's going to be a not equal for P. This is just asking you if you wanted to put your regression equation in Y1. You don't have to, so you're just going to skip that and then click calculate. So your test statistic T is given to you right here, 1.478. And then the p-value is going to be 0.183. And if I want to write correct probability notation here, this would probably be the probability of t is greater than 1.478, and then that would be times 2 because it's a two-sided. If you want the p-value for a one-sided, you have to decide which side you want. And if you wanted to do the greater than, because you have a positive test statistic, then you would just go here and you would change your LinReg t-test to a greater than, where the p is right here. So you would hit greater than, and it's really just going to be half of the p-value that you got up here, which is 0.091. Okay. And then if you want to check your conditions with the scatter plot and the normal plot, you could go to your calculator and you can turn on your scatter plot by hitting second y equals, press on, and then of course this is your scatter plot, your X and Y list are list 1 and 2, and then you would do a zoom 9. And so then you could see your scatter plot. The data does look a little bit scattered, so you may want to proceed with caution here because it really doesn't look like they're going in one straight line. You have some data that's a little bit off over here and here. And then as far as your histogram is concerned, you would do second y equals, and you would then turn on the histogram by selecting the histogram right here. And you don't want the list 1, you actually want to check list 2 because those are your y values. So then again you want to hit zoom 9, and as you can see this is not a normal distribution. It is skewed to the right with a peak on the left side over here. Your peak should be in the center. Okay? So if you have any questions, please let me know. Other than that, good luck studying, and I'll be available on Monday morning if you need any extra help.